Yeah, hello guys, welcome to Easy Tech Academy. Alright, so after watching this video, I want you to like, share, subscribe, or follow this channel. Alright, so you can also make your comment in the comment section. Love you guys. Alright.
So now, look at the two symbol. Hope you have mastered it.
Yes, sir.
Master it.
Yes.
What of Mr. Vincent?
Yes, sir.
Mr. Horizon, also you can also contribute.
Yes, sir. Yes, sir.
Now back to the schematics. So what type of MOSFET is this?
The P channel.
P channel?
Yes,
This is
sir.
the end channel. This is the end channel.
If it's P channel, what is your reason? If it's N channel, what is your proof?
Because this thing is facing opposite.
Which of the three? One,
Yeah,
two,
that one. The two.
number two.
Yeah.
So it's facing the opposite of what?
Of
Of
this.
gate.
Yeah.
What of Mr. Vincent?
No, she didn't me first. The arrow is facing the gate. It's facing the gate. So it's end channel. Yes, sir, that arrow.
So Mr. Horizon.
Yes.
So it's not facing opposite. It's facing the gate. This is the gate. So
Okay.
it's facing the gate side. So this is N channel. This is charging IC of that mobile phone. Now see what is inside. That's why I told you that the beginning for diode. From diode to what? To transistor. From transistor to MOSFET. You can see inside the IC. Now we have two components that make it a charging IC. That's transistor and the MOSFET. Yeah. So this is called BJT transistor. And this is what? This is N channel MOSFET.
Yes.
That's what makes it a charging IC. And once you understand how these components switch, we are going to read this charging IC, how it works. I think you understand. Now, let's see how it works. So, let's see the leg. This one leg. This number one, number two, number three. You can see that number one and number two are what? Are emitter, which serve as inputs. So this means that this voltage is coming from somewhere and it will enter this charging IC. Okay, so that's emitter. Now, 5 and 7. Okay, 5, 7, and 6. So the 7 leg is internal, it's inside. So it's not outside. So now, okay, sorry, it is this one that is internal. It's this one that is internal. So now, 5 and 6. At least we have 8. We have 8, but 2 here are internal. You can't see them outside. So that's why you can see only 6 pin outside. So that one is inside. Okay? Yes. So now, we have collector here, we have collector here. That's 5, that's 6, 7, and 5. So which is what? Which is our output? And what is the name of the output leg? Let's see.
VBAT.
That's VBAT. So which is our voltage that is going to the battery connector. So this is the battery connector, which is what? 4 pin. That's the ground, the negative. So that's 4 pin. But this the one, because this is the ground, this is the ground, this is the ground pin. So ground pin have two leg, but you can't see the second one is underneath of the battery. So we have 3 that you are going to see. Okay. So now this is the battery connector. Our output is feedback. Now, how this charger IC is going to switch, maintain the voltage from the input. And what is the input? That's the feed charge, also known as feed bus. This is our 5 volts coming from the charger. Okay, so that's our input. So this is the voltage that the IC is going to maintain to produce out the output, which is feedback, and the feedback voltage is in between 3.7 volts to 4.2. Okay,
Yes.
so how does it switch? Now, look, because this is a MOSFET, or let's say transistor charging IC. It is not DC to DC IC. We have some charging IC that they do something by themselves. So you'll be seeing that in Android phone. But this is just ordinary transistor or MOSFET charging IC. So it needs a control. So far, it has a gauge, it has the base, the gate. So you need something to control it. Now, this is the N channel MOSFET. This is the source. This is the gate. Okay?
Yes.
This is what I want you to understand. It is this N channel MOSFET that is going to produce a voltage to the base of this, is the one that is going to produce a voltage for this base. I think you understand.
Yes.
Good. Now let's see how it switch. So source. Let's see where the source is coming from. Now look at what is written. Gate drive. That is this that is coming from here. Gate drive. Wait, let me see where it's coming from. So this power IC, or let me just say, the mobile phone is only one chip that is controlling everything. So it serves as power IC, it serves as a CPU. So it's only one chip that is controlling everything. Okay, and this is the number of the chipsets. MT60, it's a MediaTek, MT6261. So it is, let me tell you one thing. I told you one thing in the transistor class, that in electronics, they agree that for the N channel, the voltage switch from the collector to drain, to emitter. because of how diode is placed inside it. But there are some times that it's going to change. You can change that it will come to the normal that emitter to collector. Okay.
Yes.
Now they use the principle here. So it is power IC that send this signal that we call drive. That's voltage drive. This gate drive. If you can remember when we are learning about Infinite Smart 5, Xenon X657. This signal is also the same as peak drive. If you remember, you remember.
Yes, sir.
Yes.
The feed vibe register is from the
So
CPU.
it's also the same thing. So it's coming here to the source of this N-channel MOSFET. And this voltage is around 2.8 volts. Let me try to minimize it more so that we can see everything entirely. So we are having 2.8 volts coming from the power IC, which is called
Interact.
now this voltage is coming to this place to switch this transistor. For the principle of N-channel MOSFET, the gate voltage must be greater than what? Than the voltage that is coming from the source, which is 2.8 volt, right? Now, let's see where the gate is coming from. So you can see the gate. Let's see where it's linked. It linked to this line, this P charge line, which is 5 volts. Is it not greater than 2.8 volts? Hmm?
Say,
Stars are asleep.
you say what?
I
I
said
was trying to omit my mic. Yes, sir. It's greater than 2.8 volts.
yes. So I said that the voltage is it not greater than the 2.8 volts in the source? It's greater than it. So definitely it's going to switch. So this means that we are going to have 5 volts here coming from the charger at the gate and at the source 2.8 volts. So now that voltage is going to, this is the drain. So that voltage is going to switch here and come here. We have 2.8 volts here that will turn on this. And what is the principle of PMP transistor? What is the principle?
The the base has to be
Okay,
greater than the emitter.
you are wrong. PMP
Okay,
transistor,
the emitter has to be greater than the base, sir.
correct. So now let's see the voltage that is coming to the emitter. It's also the P charge. That's 5 volts. So we already have 5 volts here. That's our emitter. We already have 2.8 volts here coming to the base. Now, uh, they are the one that know how to maintain that thing. So it's very deep. So we don't need to go look at that. Whereby this voltage is going to drop and become the one that it will require to charge the battery. So we don't need to go deeply on that. Okay? Whereby we are going to have from 3.7 volts to 4.2 volts. So it's another level of understanding. Hope you understand. So in that case, after we have that, it's going to switch. And we have our collector, which is our feedbacks. You can see how simple is what. Okay? Now for us to read what is going on here. This means that if this voltage is not present, this is not going to drive. You see that we have 5 volts here. Oh, sorry. I mean, if this gate voltage is not coming, that's 2.8 volts, not 5 volts. If it's coming here, that is, if it's not coming from the power IC, I mean, or the chipset, this transistor inside it will not drive. So we have our 5 volts here at the 2 leg. We also have our what is it called? 5 volts here also. It's linked to free charge at the gate. But this here, this collector will be 0 voltage. This also will be 0 voltage. Now, if our mobile phone is not charging, what are we going to, for those that cannot read schematics, they will just remove this and change it. Still yet, no voltage output. But where is the problem is coming from? From this. Because if this voltage doesn't come to this one will not drive. That's knowledge of schematics and how to trace a board.
Sir, if the voltage is not coming from that place, how can we do it?
Alright, I hope you enjoyed the video. Okay, so if you want to join your going on batch, so the semester 1 class of EasyTech Academy, okay, so this class is fault finding master class. Okay, so if you want to join, you can contact on the display number. Okay, so you can contact with my official number. Alright, and remember, it's a paid class. It's a paid class. Okay, alright, so and the price is displayed on the screen. So if you want to join the ongoing on batch, you can contact. Alright, bye.